Hello everyone, today let's solve the problem Buns, right? So this was asked in the Codeforces beta round 82, right, for the division 2. So let's see what the question states here. So you can just go through the question. It's easier to understand. I'll just summarize the question so that it will be easier for us to solve the problem, right? So what the question states here. So a guy named Lavrenti has n grams of dough, right? So just give me a second, 1 second. So yeah, a guy named Lavrenti has n grams of dough. So this one, n grams of dough is having, right? So just give me a second here, 1 second. Yeah, n grams of dough and m stuffing types, right? M stuffing types. I'll just write here stuffing st types, right? A guy named Lavrenti has n grams of dough and m stuffing types, right? So for stuffing I, you can make at most floor of ai comma bi, nothing but the math operation, right? Floor of ai comma bi. For stuffing I, we can make at most this one, floor of a by b, nothing but here this one is represented by ai by bi, basically in simple terms, right? So this is fine. A floor of ai by bi Buns. Each uses c grams of dough and sells for d, right? Each uses ci grams of dough and sells for di, basically. We can also make any number of plain buns without stuffing or no stuffing, right, using c0 dough and selling for this one, d0 dough, right? So this is fine. We can also make any number of plain buns, nothing but the no stuffing, using c0 dough and selling for d0. So what we need to do here, we have to maximize the total money that we can earn, right? So what we need to find, or what we need to do here, we need to maximize the total money that we can earn, right? So we have to throw away the leftovers. They have strictly mentioned in the question that we need to throw away leftovers. Just remember this one, right? So again, I'll just read out the question now. Just try to understand this one. A guy named Lavrenti has n grams of dough and m stuffing types. This one, right? N grams of dough and m stuffing types, right? So for stuffing I, we can make at most this one, floor of ai comma bi, ai by bi Buns. Each uses ci grams of dough and sells for di, right? So this one. And we can also make any number of plain buns without stuffing or no stuffing using c0 dough and selling for d0. So what we need to do here, we need to maximize total money that we can earn, and we can throw away the leftovers. Just remember this one, right? So this is fine, I believe. Now I hope the question part is completely clear, right? So just give me a second here. Yep, this one, let's come to the input output part. So this is the sample, basically 10 2 2 1 whatever they have given. So this is nothing but the sample, and this is type 1 and this is type 2. 73200 is nothing but this one, type 1, which consists of value a1, b1, c1 and d1, right? Same goes with this one. This is type 2, a2, b2, this one, c2 and the d2. 12 3 1 and 1 and 10, right? So the output that we need to get here is 241, right? So this is fine, I believe, right? So this is the this one, this is about the input output. So same goes with the second input as well, or the second example. The output that we need to get here is 200, right? So this is fine, I believe. So one thing I want to tell you here is we will be making use of the dynamic programming to solve this particular problem, right? So we can solve easily, this problem can be solved easily using the dynamic programming. So I opted DP, right? So this is fine. Just give me a second, 1 second. Yep. Now let's discuss the approach followed by the complexities, and then let's write the code. As usual, let's discuss the approach first. So I have considered the same first example that they have given in the question, right? So this is we have already discussed this one, right? So we don't have to discuss this one again. So the output that we need to get here is 241, right? So this is nothing but the sample. This is nothing but the sample. This is type T1 and this is type T2, right? So this is nothing but A1, A2, A3, A4 and followed by A2, this one second. What did I give here? Sorry, a1, b1, c1 and d1. Sorry, this one is a2, b2, c2 and d2, right? So this is fine. This is nothing but the main sample. So output that we need to get here is 241, right? So let's see the same thing. Before getting before moving on with this one, a step-by-step explanation, I just want to tell you here is we'll be making use of the dynamic programming, as I've said, right? So we'll be going with a pure classical DP to solve this particular problem, right? So let's go with the step-by-step explanation. So let's discuss the DP idea. Let's see what the DP idea is, right? So we will be treating each stuffing type as an item. So this one I found it very interesting, and this one I just wanted to explain the DP idea, right? So just listen to this. We will treat each stuffing type as an item where we may take 0 to this one max count of buns, right? So this is fine. I hope this part is clear. Just try to remember, we'll be treating each stuffing type as an item where we can take 0 to max count buns, right? So DP over items and remaining dough computes the best value. So see here, DP over items and remaining dough computes the best value. This is fine. For each item I and the capacity this one CAP, we try all the feasible counts this one CNT, and we will use DP of this one I plus 1 cap minus this one count into CI plus count into DI. So we'll be making use of this one. So just try to remember this one. We'll be using this one in the code, right? So just remember this one, right? We'll try all the feasible counts and we'll use this one, this part, DP of I plus 1 cap minus count into CI plus count into DI. This one, this is fine, I believe, right? So accordingly with the question, right? So this is the idea, man. This is the basically this is the DP idea basically, right? So let's try to apply the same thing, whatever we discussed the DP idea, right, to the sample 10 to 21, right? And the lines. So the type 1 we know this one, a1 value we have 7, b1, c1, d1, right? So 7, 3, 2 and 100. You can just check. A2 we have 12, b2 we have 3, c2 we have 1 and d2 we have 10, right? So we'll be going with a max floor of 12 by 3, nothing but the 4 buns. Plain c0 equals to 2 and d0 equals to 1, right? So this is the value that we are having. So let's move on with the next one, next main point. So we'll be going with a greedy approach. Basically what we'll be doing, we'll be going greedily. This one we'll check whether it is greedily feasible choice that DP finds, right? So let's see the same. So first we will take 2 buns of type 1, man, right? So we'll take 2 buns of type 1, so which basically uses 2 into 2 accordingly with the input, 2 into 2, nothing but the 4 dough, right? So here this one will be, this consists of the 4 dough, so which gains basically this will be 2 into 100 which will lead to 200 basically. This is fine, simple. First what we'll be doing, we'll take 2 buns of type 1, then we will use this one which basically uses 2 into 2, nothing but the 4 dough, right? So this gains 2 into 100, nothing but 200. So because we have d100 here, right? So this one, right? So we are making use of the 2 buns of type 1, nothing but this will be 2 into 2, 4 dough, which gains 2 into 100 because d1 we have this one 200. This is fine. Now what we will do, the next step, we will take 4 buns of type 2, which will be 4 into 1, which uses 4 into 1, nothing but the 4 dough, right? So again here we have d2 equals 10, right? So d2 equals 10, we are going with a 4 dough, right? So because we are making use of, or we are taking 4 buns of type 2, right? So this will be 4 into 1 4, totally it gains 4 into 10 because we have d2 equals 10 here. 4 into 10 will be 40 basically, right? So this is 200, this becomes 40. Remaining dough is nothing but, so we will be going with 10 d2 minus 4 minus 4, right? So 4 minus 4, so this will lead to 2 basically. This will be 10 minus 8, right? So in simple terms this will lead to 2. So we will be making one plain bun that gains 1 basically, right? So this will be totally 1. So this will be 200 basically, followed by 40 and 1, right? So we have to sum up these 3, right? So we have considered this one, 2 buns of type 1, 4 buns of type 2, and finally remaining dough, nothing but 10 minus 4 minus 4, in simple terms 10 minus 8, right? So this will be 200 followed by this one, what do we call, 40 followed by 1, right? So this is fine. So this one will be 241, right? So this is fine. Now we got this one total. When we summed up this one, we got 241, right? So the final output will be 241. The final output that we got is 241 basically, right? So the output that we got here is 241, which is equivalent to the output that they have mentioned for the example 1 within the question. So our approach works absolutely correct here, right? So this is 241, man. If 1 is not visible, this is 241, right? So our approach works absolutely correct, right? So as we are completely familiar with the approach, let's do one thing. Let's quickly discuss the complexities part. So what will be the time complexity here? The time complexity would lead to big of m into n square, right? So basically it will be big of n into m into n into max count per state, right? So in the worst case it would be big of m into n square. So because we are given the constraints, right? Accordingly with the constraints, this is safely small, nothing but m less than or equal to 10 and n less than or equal to 1000 basically. In the worst case it would lead to big of m into n square, this one, time complexity. So what would be the space complexity here? The space complexity would lead to big of m into n, right? So the space complexity would lead to big of m into n due to the dp table, right? So this would be dp table will be considering which will be of the size dp of m plus 2 into n plus 1, right? So this would be big of dp of m plus 2 into n plus 1, right? So the time complexity and the space complexity for the code that we'll be writing in the future would be big of m into n square and dp of m plus 2 into n plus 1 respectively, right? Big of m into n square and big of m into n, sorry, I just, this one is nothing but the dp table, size m plus 2 and n plus 1, sorry, right? So the time complexity and the space complexity for the code that we'll be writing in the future would be big of m into n square and big of m into n respectively, right? So this is fine. So now as we are completely familiar with the approach and the complexities, we are good to write the code. Let's start writing the code. So let's start writing the code. I'll just come here. So the first thing is we'll be going with this one, input output, fast input and output, right? So I'll just go with input java.input output star, and the second thing here would be, let's go with the main, this one, class basically. So I'll name, usually I name main, right? So every time, so I can just give any name that's relevant to the question basically. Let's make use of the fast input reader from the standard input. So I'll just go with the buffered reader, man. Let me go with static. So this one, buffered reader br, this is equal to new buffered reader. So this one will be new input stream reader. So this one system dot n. So this is fine. The next step would be, let's go with the fast output writer to the standard output. So I'll just go with your static. This one will be buffered writer. So I'll just go with buffered writer pw. So this one is equivalent to new buffered writer. This is fine. New output stream writer of system dot out. This is fine, man. Let's go with a temporary string array that is used to hold the split input tokens, right? So this will be static string. This is fine. Input, I'll just consider in here. This is fine, man. Let's go with the main method. So I'll just go with main. This is fine. This would be throws input output exception, right? So I'll just go with throws input output exception, right? I'll just go with or else we'll get the error, right? So within the main method, first let's read the first line and split into the tokens, nothing but this one, n, m, c0 and d0 we need to consider, right? So first let's read the first line and split into the tokens. So I'll just give here, assign the in the buffered reader dot so this one will be read line, and we will be making use of split as well, right? So this is fine. And n is nothing but the total door capacity here, and m is nothing but the number of stuffing types, right? So let's assign n to this one integer, so both are integers, right? So this one is fine, integer dot pass, and so this one will be n of 0 basically. So let me copy the same thing for the m as well and make the necessary changes, man. This is fine. So this one would be int m, this is fine. This would be 1. Yep, this is fine. Now let's do one thing. Let's prepare the plain, this one. Before doing this, so we have to go with the item of I, which will hold 4 ints for the ith item. So this one, let me do one thing. Let me go with a variable item here and assign this one to new int. Let's initialize this one with the size m plus 1, and let me go with the 4 actually. As I've said, will be this one item of I will hold the 4 integers, right? 4 ints for the ith item. So I'll be going with the 4 here. This is fine. So the next step would be, so we have to prepare the plain bun, right, as the item index m basically. So we have to make available quantity very large, so only door capacity limit set, right? So I have considered 4 here. Within this one item I have assigned this one size 4 here, right? So we will be going with here item of m0, m1, m2 and m3, right? So I'll just go with item of this one m0. So let me go with, so here this one int 1e9, right? So this is fine, man. Yep, let me copy this one, let me paste it, let me paste it. So this is fine. This one is fine. 1, this one is fine. 2, so this one is fine. 3, this one will be 1 here, this is also fine. 1, next one will be, let's go with the integer dot percent of this one. Let me go with this. So this one as well, for this one as well. So this one will be 2 and this one will be 3. This is fine, I believe. Easy, right? So this 2 and 3, because we are considering C0 and D0. So C0 is nothing but the door needed per plain bun, and D0 is nothing but the value per plain bun. We know this one from the approach, right? So we have already discussed this one. So this value 10 to the power of 9, whatever I have considered, the line number 15. So this effectively goes for the infinite stuffing grams for the dummy item basically, right? So and this one 16, so we are dividing this one dividing by this, that yields a large count basically, right? So we are just going with I'm just initializing this one with the 1. So this is fine. Next step, what we'll be doing, so we have to read m lines for the real stuffings, right? So in simple terms, we have to go with the iteration. So I'll just go with for loop here. This is fine. For this one will be in I equals 0, I less than m, so this one will be I plus plus. So within the for loop, what I'll do, let's read the next line and split into the tokens. I meant to say here n ai, bi, ci and di, right? So I'll just go with in equals buffered reader dot read line again. So again we'll be making use of the split. This is fine, man. Now so this time we'll be going with the item of this one. Instead of m, we'll be going with the I0, I1, I2 and I3, right? So this one, let me copy this one here. Let me copy anyone. This one, let me copy this one. So let me paste it over here 4 times. So this one will be I0, I this one will be 1, and this one will be 2, and this one will be 3 itself. So this one again, I'll just make this one I. Let me go with I, right? I0, I1, I2, I3. Nothing but here we have to store the totals, this one stuffing grams available for type 1, this one, and also we have to go with the stuffing grams required for bun of type I also do required per bun of type I, and finally this one item 1 3 nothing but it is the value, right? It is value per bun of type I, basically in simple terms. All are of the type integers. We have that one in the input, right? So everything is of the type integer. 10 to something they have given, right? So that part. So this one, how can we write? This one will be same thing, integer dot percent as it is integer. So this one, instead of 3, I'll just go with 0 1 2 and 3 finally. So this is fine. We are done with this part, man. I'll just come out of this one entirely. So where is for loop here? Oh, for, it's fine, man. Yep. I forgot for loop. Anyways, so let's continue, man. As I've said, we'll be going with a DP, right? So I'll just initialize DP here. New int of this one m plus 2 and this one n plus 1. This is fine. Now what we'll do, we have to iterate the items in the reverse order from item m down to the item 0. This is typical for the DP, where DP of I depends on the DP of I plus 1, the next element, right? So let's move on with the iteration part. So in simple terms, we'll be going with the reverse iteration, man, right? So I'll just go with for, so this is easy, right? Understandable. So I equals m, I greater than or equal to 0, so I minus minus. So within the for loop, so for every possible do capacity from 1 to n, 0 is implicitly 0. So again we'll be going with one more iteration part here. So for the capacity part, right? So this will be int capacity equals 1, capacity less than or equal to n capacity. We have to increment this one, right? So this is fine. So within this for loop, first let's go with the best value for this I comma cap pair, right? So let me assign best to 0. This is fine. The next part would be, so we have to go with the maximum number of buns of this item that we can make, that is limited by stuffing availability and the dough availability, right? So we have discussed this one in the approach. In simple terms, I had said that we'll be going with the floor of AI by BI, right? So this is nothing but floor of AI by BI is nothing but item of I0 by item of I1, right? So this is for the stuffing availability, and we second one we have to go with the dough availability as well, meaning this will be floor of capacity by CI, nothing but capacity by item of this one I2, right? So let's try to implement the same thing in the form of code here. So this one will be int, let me go with max count variable name, so I'll just go with math.min here. So this one will be item of I0, this is fine, by item of I this one 1, so this is also fine. This one will be capacity by item this one of I, this one is 2. This is fine, man. Yep. Let's go with the for loop. So let's try taking the count equals 0 to max count buns of item I. So this will be for loop. So this one will be again iteration part. We have considered C and T, right? Already. Let me consider. We haven't considered yet. This is fine. Count less than or equal to this one has to be max count. Finally, let's increment the count here. So within this for loop, what we need to do, so we have to consider the value if we take the count buns of item I, right? So we will be going with the count into value per bun plus best value using the remaining dough with the items I plus 1, right? So I'll just go with here int value equals count into item. So this one item of I3 plus dp of I plus 1, this is fair. So this one will be capacity minus count, this is also fine, into item of this one, what do we call, I and 2. So this is fine, man, right? Next step is we have to keep the maximum over all the count choices. So this one will be if value greater than best. So let me assign best to the value. This is fine. Let me come out of this one entirely. Now we have to save the best value that is found for the dp of I and capacity. So this one will be dp of I capacity. So this is equivalent to the best. So this is fine, man. Let me come out of this one entirely. So final answer is nothing but, so we have to use all the items that is starting from the 0 with the full do n. So this one will be buffered writer dot, I'll just go with the right here. We go with the right. So this one will be dp of 0. Yep. N, this is also fine, plus let me go with the slash new line, right? So this is fine, man. So let me make use of the, what do we call here, double inverted comma. So why this is taking like this? Yeah, this is fine. Finally we have to flush the output. So I can just go with buffered writer dot flush, or we can just make use of the close as well. I'll just go with the flush instead, right? So this is fine, man. We are done with the coding part. So this is it for the code. Simple, right? So this is fine. Now before checking the code with the different inputs, I'll just copy paste the signature starter template. Just so let me come here, let me paste it over here. This is fine. Yep. I'll just come here. Let me consider this one. So output that I need to get here is 241. Let's check the same here. I'll just paste this one and run this one. Yeah, we are getting the output 241. This works absolutely correct, right? So this is fine. Let me consider second input. We need to get the output 200. Let's check the same. So yeah, we are getting the output 200. So our approach and the code works absolutely correct for this one, right? So it is working for the inputs that they have given in the question. Basically, let's check whether this works for all the test cases. Let me come here to the question. Let me hit the submit button. Let's wait for some time. Yeah, I'll just paste the code here and hit the submit button. I hope this works for all the test cases, man. Let's see. In queue. Let's wait for some time. So yeah, in the toast it is showing accepted, right? So the verdict that we got here is accepted. Simple. So the code that we got here is the code that we wrote works absolutely correct for all the test cases, right? So yep, this is it for the question, right? So this is it for the basically this one question 106C buns, basically, right? So we went with the classical DP type, right? So we went with a classical this one classic DP for this one particular problem, to solve this particular problem, right? So I hope the solution part is completely clear along with the approach and the complexities. For now, this is it. Thanks for watching, guys.